Welcome to setting up an object storage as a service on top of Kubernetes. My name is Daniel Valdivia and I'll be your host. So recently, object storage has been getting a lot of momentum about being the right technology for cloud native deployments. This is due to its characteristics. It's very easy to deploy, it's very easy to scale, and it's also very easy to adopt in cloud native applications, right? So let's go over the details of what makes object storage very attractive to adopt into your cloud native infrastructure. Starting with the APIs, object storage APIs are pretty much RESTful. They are pretty easy to consume. You could even consume them with curl. You don't need any specialized SDKs. You can just do everything over HTTP. POSIX is pretty much considered a legacy API at this point, and it's actually been removed from most of the applications. Just think about it. You don't want to be deploying block storage or file storage on top of AWS because it's going to cost you 3 to 10 times more than the counterpart on S3. So this is one of the many reasons why moving away from the POSIX API for your application deployment is pretty much a good idea. Next one is scale, right? You want to pick an object storage solution that can scale from petabytes to exabyte without actually having the strong requirement for you to procure specialized hardware of appliances. An object storage should also be efficient and resilient. You want to pick a solution that's protecting the data on its own, and it's not actually relying on the storage infrastructure to protect the data itself. You no longer want to be deploying additionally on EBS volumes to protect the data, right, and snapshot the data, right? You want the data to be protected by design. This will also give you some resiliency to failures, right? You want to be protected against individual drive failures and individual node failures. So that's another very important attribute of cloud native object storage. Now, a modern object storage should also be Kubernetes native, right? Kubernetes has proven to be the best way to automate and scale applications on the internet. Not only that, having the applications being deployed natively, cloud natively on your premise deployment and have the guarantee that they will work the same on the cloud deployments is just something that is unmatched, unheard in the industry, right? So this takes us to the next step, right? So if you're already betting big on Kubernetes, you have to make sure that your object storage solution is software defined. You simply cannot containerize an appliance. And that's very important. You don't want to be constrained by the number of appliances that you have previously purchased and wait until the next appliance is procured. If you need more capacity at this moment, you just want to be able to scale it up, just like any Kubernetes concept. And that's something I will touch in the next slide. And it also needs to be performant. It should be capable to scale to hundreds of gigabytes a second with both encrypted and unencrypted payloads without actually dropping a sweat, right? So that's why it's very important that the solution being native to Kubernetes, software defined, and performant. It's because of all these attributes. It's designed to scale horizontally, right? You need more capacity, you need more performance, then you can pretty much add more nodes. So what is a legacy object storage? And pretty much the one of solution that you don't want to pick for setting up an object storage as a service. That is, having a dependency on storage appliances, right? As I mentioned before, you cannot containerize these, right? Traditionally, you will set up your cloud native application on a Kubernetes cluster, and then you will go be piping requests into an appliance. But the problem is that these appliances, you cannot deploy them on the cloud and get exactly the same service, right? You're tied to a specific version of hardware, and these are proprietary, and you also need a lot of manual labor to keep them up to date. So that's definitely not something you want. You want something that's more in tune with the Kubernetes application ecosystem provides, which is applications are native. You manage them through a single pane of glass, right? You do kubectl to scale your applications, deploy them, upgrade them. This is what the Kubernetes is bringing to the table, is actually making things scale very easily. And now you can trust that if it's running on your Kubernetes cluster, it will also run on your premise deployment, and it will also run the same on any cloud. So this is where a software-defined object storage is very important. So here's the problem that organizations are coming to realize. Object storage is the one storage technology that they need to scale to petabytes, exabytes in size, but then that requires a lot of automation, and that's exactly what Kubernetes comes and brings to the table, right? A high degree of automation that makes things just work out of the box, right? However, Kubernetes has its learning curve, but luckily enough, with the operator pattern, you can pretty much get nice solutions out there that pretty much package away all the complexity so that you only need to deploy them and then just use them. And that's pretty much what I'll be doing in my demo in the next part, right? I'll be showing you how to set up object storage as a service pretty quickly using just Kubernetes and MinIO Operator. All right, let's get started. I'm going to start by installing the kubectl MinIO plugin to actually get my operator up and running in a very easy and automated fashion, right? With Crew, it's just a breeze getting things running. Next, what I'm going to do is actually use the MinIO Crew plugin to actually install the MinIO operator on its own. So what I'm going to do is type now kubectl MinIO init. And what this is going to do is going to install everything that I need on my Kubernetes cluster, right? So it's going to create a namespace, which is, by the way, customizable. It's going to install the cluster roles, service accounts, everything that I need to get started. I even propose a command that I can use to pretty much log in straight into my operator UI and start provisioning object storage. So I'm going to use this command, kubectl MinIO proxy, to actually start a port forward service automatically. It's even going to offer me a JWT token that I can use to immediately authenticate against this. So I'm going to go in my browser to localhost 9090. After going to localhost 9090 on my browser, I'll be greeted with a UI where I can actually enter the JWT token that the kubectl MinIO proxy command offered me. And I'll just hit login. And that's it. I can use this graphical user interface to actually provision very quickly new object storage tenants. Tenant is an analogy that we use to describe an object storage deployment. Pretty much the idea is that in the same Kubernetes cluster, you can deploy multiple tenants, all of them with different capacities, different configurations, right? Perhaps you are servicing multiple business units or a multitude of teams inside your organization, or simply just different customers. And you want to be able to have them on separate versions, different capacities, different configurations, and all of this is possible with the MinIO operator. So let's get started. All right, so let's get started provisioning a tenant. Let's say I'll be creating a tenant where I actually want to store some big data files. So perhaps I'm going to pick a namespace here. And what this is going to do is it's actually going to expose me all the storage classes that are available to this namespace. Mainly, if there's any resource quota limiting resources on that namespace, we will also want to honor it. And the whole idea of letting you pick the storage class here is that you can pick which is the storage technology that you want to use to back up this tenant. Perhaps, for big data storage, doesn't really make sense to spend my NVMe drives or my SSDs, right? Perhaps for big storage, we need something that's big and deep. So I'll be using standard drives. And the fact that I'm picking hard disk drives doesn't really worry me, right? So MinIO can actually scale horizontally. And the more servers I throw at the problem, MinIO will read and write in a distributed manner across all the drives, pretty much aggregating the throughput across all these disks. So if for the big data, pretty much what I need is a lot of capacity. So I think spinning drives is the right choice for this tenant. So if I were to go into my next screen, I would pretty much go into sizing this object storage. But I want to take a detour through the advanced setup so I can show you all the little things you can configure. For example, you can configure if you want to use a custom image and a private repository. This is pretty useful if you have a private Docker registry. Perhaps you're doing a deployment on an air-gap environment, or simply just want to deploy an air-gap, or simply you just want to deploy a hardened image of MinIO. You can pretty much do that. I can also control pretty much if I want the services on top of my object storage to be exposed. This is be defined as type load balancer, but perhaps I don't want to do that, right? So there may be valid reasons like I only want to consume this inside my Kubernetes cluster. Perhaps I want to set up an ingress controller myself that follows what my organization has stipulated. For this demo, I'm just going to continue with the MinIO as a service. On the next part, I'm going to set up access control into the system. MinIO comes with its own built-in IDP where I can just set up users and groups for managed access. But if your organization is actually using an OpenID directory to pretty much control access to your applications, you can configure it here. And you see, we make it pretty easy. You only need 3 fields to get it up and running. Or additionally, if you have Active Directory has some additional fields that you need to configure. But again, we try to make it simple and tell you, okay, these are the 3 things that you need to configure to get it up and running. So right now for this demo, I'm actually going to go with built-in. Next is security. So by default, we turn on TLS and we encrypt all the communication between MinIO pods. And then we issue the certificates using Kubernetes internal certificate signing request so that you don't have to do anything. However, MinIO also supports doing TLS termination, and some companies like actually terminating it that way. So you can bring all the certificates for MinIO to terminate TLS at the MinIO site, also for its management console. Additionally, perhaps you don't want us to manage the internode communication certificates automatically for you. You can disable that, and then you also can bring the certificates for internode communication. So for this demo, I'm just going to go with manage certificates for me. I just want to keep it easy. So once established a secure communication channel, we can also talk about an encryption at rest. So through the operator UI, I can pretty much configure the four most popular KMSs out there: HashiCorp Vault, AWS KMS, Gemalto, and Google Cloud. But of course, I'm not bound by these ones. We actually support a few extra. But again, we're trying to make it very simple and straightforward. For example, if you need HashiCorp Vault, you only need an endpoint, an app role secret, and an app role ID. However, HashiCorp Vault exposes all these extra fields that you can configure, and we also make it optional. Perhaps you want to configure the timeout, or you want to enable mutual TLS. That's sort of the things, and we're trying to make it extremely simple so that you're not writing YAML, right? You're just clicking through what actually is that you need. So the last step is sizing the tenant. This is the screen that I will have reached if from the beginning I will have just named the tenant, pick the namespace, and then hit next. However, now this is the part where I'm actually able to size the tenant and see what's going to happen. I can pick things like number of servers. Let's say, for the sake of example, I can pick more than what my Kubernetes cluster has in this talk. Let's say I'll pick 32 and perhaps 16 drives. Let's say I'm building something very large. And perhaps let's say I'm building something to the tune of 100 petabytes. Let's see what happens. I can pick also the amount of memory that I want on a per pod basis, and also the erasure coding parity. Erasure coding is how actually MinIO protects the data from failure, right? So this will actually take every file and chunk it into different data chunks and parity chunks and distribute across all the pods and all the PVCs to protect the data from failure. Now, the idea of this screen is that you get a sense of what's going to happen, right? So you can see the number of servers that you're provisioning, the number of drives, and the total number of volumes. Additionally, you can see a preview of what's going to happen. You can see, for example, because I picked up an erasure coding value of 8, right? So what this is going to do is that out of the 100 petabytes that I'm provisioning on this setup, 50 petabytes will be my usable capacity. Now, this is because we're actually taking half of that raw capacity for parity, right? But then this is also giving me that I can tolerate 16 server failures. This is pretty convenient because I get I'm pretty much knowing ahead of time how many server failures I can tolerate. Of course, perhaps this is for backups, as we said, or for big data, and I don't need such strong guarantees on this setup. And what is the likelihood of 16 servers failing at the same time? So perhaps I can pick a smaller erasure coding value. Let's go back to 4, which is what originally the interface was proposing. And I can see that with erasure coding 4, out of the 100 petabytes that I'm actually provisioning, 75 will be usable, right? So I've increased, and actually I reduced the number of server failures I can tolerate, but still it's pretty beefy, right? So I can still tolerate in 8 pods going down. It's pretty attractive, right? So now I have a good understanding of the SLA that I can give to my business unit or my customers about, how many failures I can tolerate, and the data will still be accessible. That's very important. So let's go back to a basic configuration that this setup can take, and then let's hit next. Now I'm going to get a review of what's about to happen. Pretty straightforward because we kept all the healthy defaults that we propose. I'm just going to hit create. This is going to throw some credentials that I can use to actually log in into my tenant. And so I'll back them up and then hit not. And that's pretty much it. Now I'll be waiting a couple of minutes for this tenant to actually provision. After a couple of minutes, I can see that my tenant has properly initialized. This means it's ready for consumption. Right, I can go here inside my tenant details and see, and probably expand it if I needed to add some extra capacity. I can also perform updates and see what's the status of the system. Now let's go back to my terminal and see what actually this translated to. So if I go to the namespace where I actually installed this tenant, I can see that the MinIO Operator actually took the effort to provision and set up all the necessary configurations. I didn't actually have to move a thing. So now with this in mind, I'm just going to start port forwarding to my console to actually see how I can actually manage my object storage itself. So I can port forward my access to the console and going to my browser to the port that I just port forwarded. So after going to the port forward address in my browser, I can see the management console login prompt. This is where I can actually take the access key as a secret key that I saw when I actually provisioned the tenant. I'm pretty much going to my system. I'll be greeted by a set of monitoring metrics, right? So right now this is a brand new tenant, there's nothing much going on, but I can see already an object browser. I can come and see, perhaps let's make a new buckets, right? So let's say I'll be putting data sets on this one. And perhaps I need versioning in case data sets getting replaced. I can see enable other features such as locking, quota retention. These are all features that come standard with MinIO, but the whole idea is that now it's all about self-service. You can now delegate access to this management console to your business organizations, and they can go on and manage the object storage. It's just that easy. Okay, so let's wrap up. Pretty much what I just showed you across this demo is how easy it is actually to set up an object storage as a service. The idea being, I took a very standard Kubernetes deployment, and I just installed through our kubectl MinIO plugin. Additionally, we have support for Helm and Kustomize. So you can just pretty much get with any deployment technology that you prefer, MinIO Operator installed in just a minute. And with that, it's pretty straightforward to actually provision additional tenants with different capacity, different configuration. It's up to you. You pick, right? It was very simple, right? Simplicity is power, and pretty much the fact that MinIO is software defined made it so that it was just a breeze to actually size and scale and configure my tenant. I didn't actually have to go to anyone to actually get it properly tweak or configure or be constrained by the size of my appliances. And this is very powerful, right? The fact that you can pretty much take on and build object storage in a matter of minutes, it's just wonderful, right? So my name is Daniel Valdivia, and this has been my talk about setting up an object storage. I'm looking forward to your questions. Thank you for your time, and talk to you later.